Hello everyone, I decided to make a more compact tutorial of access control in Linux system. So first of all, let's review the three categories of users for a file in a Linux system. We have introduced that for a file, there are three types of users: the owner, the group user, and other users. It's the three categories. So for each file in a Linux system, it is associated with the three types of users. And there are each of this group, and they could be different permission rights for these users to access the file. So we have three types of permission rights: read, write, and execute for a file in a Linux system. These permission rights can be represented by letters or can be by digits. So we have read, write permission, and execute. These three different access rights to a file. And if we write it, if we indicate each of these access rights by bit, so we have 3 bits. Then we can consider the read-write is the most significant bit. Write permission is in the middle, and the execute write is the least significant bit in this 3 bit. So it means that if we want to express the access right to a file, then we can use these 3 letters to indicate this the user has this specific access right. If the user does not have the access right, then we can use this dash to indicate there's no such access right to the file for this user. Then we can express these 3 bits as if the user has right, then we have 1. If does not have right, we have 0. So for example, for this access right, then we have 1, 1, 1. It's 1, 1, 1. It's in binary, then it equals 7. If we have another example, let's say this example, then it means the first bit is 1, the middle bit is 0, the last bit is 1. Then we have 5. If we have another one, let's say R and 2 dashes, then it equals the first bit 1, the other 2 bits are 0, then we have 4. It means that if we have access right represented by RWX, R-X, R-, then we can represent as 7, 5, and 4. So these are the 2 ways of express the access rights of the owner of the file, the group user of the file, and the other users in the system to this file. And we can write these 2 ways for expressing the access right to the file. Now we can go through with some small demo of different categories to learn this access right in better way. So let's start with file creation. If we want to create a file, let's say text file, then we can either use a Vim or other text editor. So for example, here I use Vim to create a file, file1.text. And I just, this is a test file. And I use escape to change to normal mode, and with a shift colon. And here we have this colon here. I can write W, to write Q, that's quit. In this way, this two key save the content in the file and then quit the text editor. I will create a screen, and I can use cat to see the file. Now we may want to know, when we create this new file, what is permission right for different users for this file. And we can use list and with -l too. And we can list this file. Now here, the first is the file type, and the file type of this file. So it means it's a normal file. It's not a directory. Then we have the first field for the owner. It's from what we have learned, it's 6. And for the second field, it's a 4. For third field, it's a 4. So we have this 644 for this file. So what about I create another file? Let's say echo. I just use another way to create the file, and use echo to output this text to this file. If I print, so if I print this file, these two files, then I get this list. Here I use this star as a wildcard to indicate this field can be any character. So then in the folder, I have this file1 and file2.txt. So you see here, if I create another file, it is also the same permission right. There's 6, 4, and 4. Let's say, what about I create a new folder? So I create make directory. This command. Now I create nice folder 1 and make directory folder 2. If I want to know the access rights for these two folders, so I have to give this to list all the files in this directory. Then you see I have these two the same access right to these folders. So the reason is in the system, in Linux system, it has a predefined access right for the files and for the folder. And this initial predefined access right, it's called predefined initial permission. In Linux system, it's for files, it equals 666. For directory, it equals 777. So these two are the pre-initial permission for the files and the folder in Linux system when we create new files. And there's another related value called Umask. This Umask is used to define the default permission rights to files and the directory in the system. At the moment, it is the Umask value is 0022. In the lecture, one student asked me what this 0 indicates. I checked. This is the protection bit of the file, but for the command umask, it cannot modify this value, so it will be always 0 for the first bit, and for the remaining 3 bits, it is used to define the default permission rights for new files and new directories. And the rule is the default permission equals the predefined initial permission minus the value of umask. So if we take so we have this formula. If we think of the new umask value, that's 022, it means that for files, the default value permission is 666 minus 022. And this subtraction is bit by bit. So we have 644. And for folders, it's 777 minus 022. It equals 755. Now, is that correct? Then we can list file 1.txt. I can list all of them. So for file 1, it's 644. File 2, it's 644. For folder 1, it's 7, 5, and 5. This is how it works. Well, what we can do is umask. Actually, it can be used to change the default permission when we create new files in a folder. For example, I can change, let's say, umask, and it is previously it's a 022. I change to 042. And in this way, if I create a new file, text file 3.txt, txt. I already have this file 5. Then if I print the permission right of this new file, so it becomes like this. So this right is 6, 2, and 4 equals 666 minus the umask value, that's 042. We have set umask, it's 042. The first bit is to be excluded. It's for protection bit. And if we create a new folder, let's make directory folder 3. We check folder 3. So the value is 7, 3, and 5. So it equals, if it minus this 0, 4, 2. Excuse me. If we have 7, 7, 7 minus this one, it equals 0, 4, and 2. This is what we can do with Umask. And here it's necessary to note that this Umask can only change the permission, default permission right within the range of the predefined initial permission. It means that we cannot change the permission right larger than 666 for a file. And if we want to do that, we have to use other commands. More specifically, change mode for that file.